Good morning, students. Today we are going to discuss IIT-JEE NEET Foundation. See the topic sound. Sound is a form of energy which is produced by the vibrating bodies. Sound is a form of energy which is produced by the vibrating bodies. There are different types of sounds are there. See, infrasonics, ultrasonics and audible range. If the frequency of the sound is less than 20 Hz, see such sounds are called infrasonics. If the frequency of the sound is greater than 20,000 Hz, that is called ultrasonics. If the frequency lies between 20 to 20,000 Hz, that is audible range. So in the sound we have, there is how sound energy is propagated. When I am talking here, my vocal cords are vibrating. Due to the vibration of vocal cords, the sound is produced, and that sound is propagating through the medium like air surrounded by me. In the air, see, air is a medium which is having the properties like elasticity and inertia. So those properties which helps to propagate the sound from one place to another place. See, transverse energy by pushing adjacent molecules and adjacent particles. So transverse energy without transporting themselves. This is called propagation of the sound. Once if it reaches to your ear, the eardrum starts vibrating, tympanum, that sends the information to the brain and you can hear the sound. This is called persistence of hearing. The persistence of hearing is 0.1 seconds. One sound to another sound. The difference between the time lag between the sounds is 0.1 seconds. So this is happening when sound is produced. See, in the sound, the main thing is the sound. Okay, see, the study about sound in the physics is called acoustics. Acoustics is the sound, and basically sound waves are the longitudinal waves are sound waves are longitudinal waves, and light waves are transverse waves. See, longitudinal wave is nothing but, see, the vibration of the particle or the producer source, whatever vibrating. For example, you take a tuning fork. The tuning fork vibrates. Due to the vibration, those particles are going to vibrate and transfers the energy. When the propagation of the wave is parallel to the direction of vibration, or see, the vibrating particle, if the direction of vibrating particle is parallel to the direction of wave propagation, such waves are called longitudinal waves. If it is not parallel, if the direction of propagation is perpendicular to the wave propagation, if the direction of propagation is perpendicular to the direction of vibrating particle, such case we will call it as a transverse wave. See, here sound waves are longitudinal waves. The sound propagation, see, the sound waves, sound propagation, how it is going to be there. The sound waves, the speed of the sound and intensity, and transverse waves, longitudinal waves. See, longitudinal waves, the sound. For a transverse wave, the displacement of medium is perpendicular to the direction of the propagation. I told you, in the ripples, see, a ripple on a pond, wave in a string are visualized like this. See, in this case, if you observe carefully, the transverse waves, the particles vibration will be like this. This is the particle vibration, but the direction of propagation of a wave is perpendicular. The direction of propagation of a wave is perpendicular. So such waves we are calling it as a transverse waves. See, transverse waves cannot propagate in the gas and or liquid because there is no mechanism. See, something like a driving motion. See, there is no mechanism for driving motion. That's why, there is no such thing like the propagation will take place. But in the case of the longitudinal wave, the longitudinal waves, the displacement of particle, the displacement, okay, of the medium parallel to the propagation of the wave. Displacement of medium is parallel to the propagation of a wave. So in this case, the propagation of a wave and the particle or medium of the particles, the particles of a medium will be parallel. So here there is a compression and rarefactions are going to be there. In the previous case, crusts and troughs are going to come. Okay, so compression means where the particles are very closer, the volume is less and pressure is more. See, that is called compression. And rarefaction is nothing but, so where volume is more and pressure is less, so that is called rarefaction. In the longitudinal waves, see, sound waves are longitudinal. So these sound waves are going to be the have the something like, see, there are compressions and rarefactions will be there in the sound waves in the air. See, in the air there is a increased pressure and decreased pressure. Due to this increased pressure and decreased pressure, if you observe here, a single frequency of traveling through the air medium, it causes sinusoidal pressure waves. Sinusoidal means like up and down, up and down. See, something like a sine wave, sine wave, see, like music, okay, see, like tide or so these type of wave propagation. The air motion of which see the passage of the sound waves back and forth. Due to this motion, okay, see, there are actually different types of motions are there. One is vibratory motion, periodic motion. Vibration motion is to and fro motion, they travels, okay, back and forth, that is vibratory or oscillatory motion. Periodic is nothing but if the body repeatedly travels along the same path in equal intervals of time, that is periodic motion. Here the particles are vibrating and the propagation of the sound. So the longitudinal wave, here there is an increase of pressure. Increase of pressure, the molecules, if you observe here, the molecules are very close. So the molecules are very close. This area, if you observe carefully, this area, the molecules are very close. See, these are called compressions. These are called compressions. See, compressions, these are called compressions. And these, whatever the molecules are not closer, those areas, what we will call it as a rarefactions. This is rarefaction, rarefaction, rarefaction. So compression to compression, the distance between successive compression is nothing but wavelength. It is denoted by lambda. Lambda is the symbol of wavelength. Lambda is the symbol of wavelength. The successive compression means one compression and adjacent compression. See, the distance between two adjacent compressions or the distance between two adjacent rarefactions or successive rarefactions is called lambda. Lambda is the wavelength. What is wavelength? The distance between two particles which are vibrating in the same phase. Phase nothing but the position and the instantaneous position and direction of a particle. The instantaneous position and direction of a particle is called phase. So where all particles will have same phase, so that distance between two particles which are in the same phase, they are the same phase, they are here compression. So the distance between two successive compressions is nothing but wavelength. That you have to remember. And there are definitions like time period, the time taken to complete one compression and one rarefaction. That is complete one full wave. One full wave is one compression, one rarefaction. So like that, the time period. Frequency, the number of waves produced in 1 second. The number of waves produced in 1 second is frequency. Frequency units are hertz. Hertz is the SI unit. There are some other velocity of a wave, velocity or speed of a wave. The speed of a wave is nothing but distance travelled by a wave in 1 second is called speed of a wave. The speed is equal to V is equal to n lambda. The formula for speed is V is equal to n lambda. See, and if you observe here, here there are successive compressions and a low frequency. These are the, see how this, actually there is a scientist, physics professor, Client Spot of the university, shows the way visualize these longitudinal pressure waves in the Wonders of Physics, demonstrates the show. A loudspeaker is driven by the tone generator, produces a single frequency, the sounds in a wave, so in which the gas is filled. A series of holes are drilled in the pipe, release a small amount of gas. Igniting the gas produces the flames, which is the highest increases with the roughly measuring the wavelength, the pressure on the pressure wave in the pipe. If you are having a low frequency, if you observe these flames, this is the gas pipe. A small holes are so made in the hole, made in that. Then automatically the flame, how it is going to come. If you observe, if it is a low frequency, this is the type of flame. If it is a high frequency, the flames are igniting. From this you can understand that. See, there is a series of small holes are drilled at regular intervals of the pipe. They appeared about 1 mm apart. So this is all just to understand longitudinal waves, how they are going to have the pressure variations. Due to these pressure variations, the compressions and rarefactions are formed in the longitudinal waves. So this is about longitudinal wave, sound waves in the air. And coming to the, see, sound waves. In the sound waves, see, important one is, see, what is the speed of the sound? Speed of the sound in the gases and the speed of the sound in solids, speed of the sound in liquids. See, which is the speedest? The speed of sound in vacuum is 0. Speed of sound in vacuum is 0 because sound waves are longitudinal waves. The medium is necessary. Vacuum does not have a medium. Hence, sound cannot propagate through vacuum. So, the speed of sound in the solids is greater than that of liquids and greater than that of gases. So you can understand the speed of sound is maximum in solids and minimum in the gases. In the air, in the vacuum, it is 0. The speed of sound in vacuum will be 0. See, the sound speed in gases. By using this formula, this famous formula, gamma RT by capital M. Gamma is the adiabatic index, R is the gas constant, and T is the absolute temperature. M is molecular mass of the gas. If you use this formula, R is gas constant, adiabatic constant is 1.4. If you use this formula, you are indirectly, the speed of the sound is directly proportional to square root of temperature, 20.05 square root of temperature you are going to get. That is, V is directly proportional to root T. V is directly proportional to root T. See the speeds, how the speeds are going to be there, we'll discuss. The speed of sound in the air is 331.4. So plus or minus, plus approximately 0.6 Tc. Tc is the, see, the temperature in Celsius. Celsius temperature. If you take a Celsius temperature, you are going to get these values. The speed of the sound at a temperature of, let us say, 50 degrees. At a temperature of 50 degrees, what will be the speed of the sound? At a temperature of 50 degrees, the sound speed is 331 plus 50 into 0.6. That becomes 361.9 meters per second. See, this is 331.4 is speed of sound in air. Because of temperature, see, the speed of sound is directly proportional to temperature, root of temperature, absolute temperature, that only which gives approximately, see, speed of sound at a temperature of 50 degrees, it is 361.9. You can calculate like that the speed of the sounds. And coming to the solids, And the important one, there is, see, speed of sound in gases. And in the, see, there are some musical instruments in the sounds. There are three types of musical instruments. Music is nothing but a sound which is pleasant to hear, is called music. Noise, the sound which is not pleasant to hear, that is called noise. The musical instruments you take, there is, see, something like a string type instruments like veena or guitar, etc. These are string type instruments. There is a string will be there, the string vibrates and produces sound. Those sounds which is very pleasant to hear, so that is string type instruments. Another one is blow type instruments. Blow type instruments are nothing but there is a column will be there. So see, something like in marriage function hall and sannai, okay, so we use that a big pipe will be there, that air column produces sound, that is blow type instruments. Another one, drum type instruments. Drum, there is special material which is having membrane something, so with that you are vibrating the, so that is going to have the sound, that is drum type instruments. Mridangam, tabla, all these are drum type instruments. All these are different musical instruments. See, these musical instruments like string instruments, woodwind instruments, so many instruments like piano and all these things, different types of instruments which produces sounds, which are going to have the sound. See, the string type instruments, I told you, there is a string type instruments like violin, so guitar, etc. All these are string type instruments. See, double bass and electric guitars, all those things are the, so string type instruments. If you take, see, woodwind instruments, these are woodwind instruments like saxophone and clarinet, etc. There is a blow type, that is also called blow type instruments. Blow type instruments. And brass instruments, these are all on type of brass type instruments. These are also similar to that only. So trumpet and French horn, all those things. And percussion instruments, these are like bell, timpani, snare drum, bass drum, drum type. These are all like different drum type. You are going to have this. And piano and others. And there is a piano and organ type instruments. See, voice, there is, I told you in the beginning of the video how sound is propagating. My vocal cords are vibrating, tympanum, eardrum, through that which is going to reach, and you will get the resonance takes place. It's a phenomena. Resonance is the phenomena in which two bodies vibrates with the same frequency, something like, so one is vibrates due to the other. See, other body starts vibrating due to the first one, so that will takes place here. Due to that only all this will takes place. So thank you very much. We'll continue in the next video.